Hello, good afternoon. So, continue from previous classes or previous video. Now I am going to teach the how we measure the expectation value. Why it is always use the term expectation. See, in expectation value, or mean value. So why mean value is necessary? In previous my classes, video classes of statistical mechanics, I told you any macro state is defined as, this is a macro state of n numbers of particles, n1 particle, n2, n numbers of particles. N number of particles occupied volume V with energy E. Okay, a macro state is defined with energy E, total n numbers of particles, and with volume V, occupied volume V, and total number of n particles. So this system can stay in three different states: psi 1, psi 2, psi 3. Okay. This macro state has three different macro states. Okay. That means what? This whole system can stay at this state, at this state, at this state. For example, if I consider group of students staying, they can stay in Jorhat, they can stay in Tezpur, they can stay in Guwahati. The three possible macro states. This group of students is represent macro state. Similarly, in quantum mechanics, that is why we always need a sample theory to describe statistical system. Similarly, in quantum mechanics also, any quantum mechanical system is represented as wave function, is represented in terms of basis vector, Okay, this means that these are the macro state. This is the whole system, whole macro state. This system can stay in this state also, this state also, this state also. And in quantum mechanics, exact location, exact state of the system we don't know. That is why we represent as superposition principle. Superposition principle, that these are the basis vector. These are the in statistical language it is called macro state. It can stay here, it can stay here, it can stay here. So that is why number of possible basis vector is available. Okay, these are the macro state. So that is why we always use the term expectation value, mean or average value of this parameter, any parameter. So how can you represent expectation value? Expectation value is always represent any operator. Operator means physically observable, maybe momentum, maybe energy, maybe angular momentum, anything, physical measurable quantity. So it is written as this is normalization condition. It will give total probability. Always remember. Normalization condition. This condition you remember in the discrete mathematics it is represented like this. In continuous mathematics it is 0 to infinity psi star dx equal to 1. It is total probability. Okay. It is total probability. So this equal to wave function a. Okay, it is always represented by this. And if we expand, if also we know a operator with function this part if you see operator, then a n psi we get this eigenvalue. This is the eigenvalue equation that we have learned from the postulate number 3. Okay, measurement and eigenvalue. So if we replace that equation, we will get sum of a n psi. If we replace this equation, then we often get this equation. If we replace this equation, and this will measure what? We have already told you. This will measure the probability of finding the system in state 5. This term measure. So it will become an into en. So if we want to measure the expectation value of an operator, then you have to multiply. It is a total sum, algebraic sum of probability coefficient, coefficient of the wave function, okay, and with the probability of that state. Okay, suppose in statistical system, suppose n number of particle, volume V, energy E, this system has three orientation, three possible microstate. And in statistical, in condensed matter physics, it is has number of possible mode of vibration. In spectroscopy, number of possible mode of vibration, and in quantum mechanics is a possible basis state. And statistics it is called number of possible microstate. All language is different, but meaning is same. So this is the macrostate. Suppose this is state, this state, this state. Three possible state is there. So three possible microstate or basis vector. Then wave function we will represent A1, I1, A2, I2 plus A3, IT. In this case, if you want to measure expectation value of energy, suppose expectation value of energy, see, now it is abbreviated A operator, any operator. So I have the expectation value of energy, replace A with by E energy, then I will write, first I will write in terms of A equal to A and E. Okay. Now if I convert this equation expectation value of energy, then what I will write? I will write En. Okay, remember. Now it is E, that is why I write En and P. So what does it mean? In this case, three possible states here. So I will write E1, P1, E2, P2 plus E3, P3. This is the meaning. So if we want to measure the mean value of this system, in this case, where there is a three possible microstate or three possible quantum mechanical substate, then what happens? Energy of this state, this is suppose energy E1, this is suppose energy E2, this is suppose energy E3. Meaning is that whenever this microstate, this system stay at this level phi 1, then it has energy E1. Okay, and whenever this system stay in energy E2, then it will have energy E2. Similarly, whenever this system stay phi 3, with energy will be E3. Then this is the equation. Okay. Corresponding energy of the state with multiply with the probability of this state. So this is the expression. Now suppose this equation I am writing again to make you understand in better way. Phi 2, phi 1, phi A2, phi 2 plus A3, phi 3. Okay. Now what is the probability? Probability in terms of An. An equal to, we know the formula, psi into phi, psi n into phi square. So if you get this, if we multiply with this bra notation with cat notation, you will get this square, sum of A n square. Okay, and this will be this one. So this way you can find out the probability and product the energy. Now you will not understand. Whenever I give you the one or two numerical problem, you will understand. Okay. But what is the difference between statistics and in quantum mechanics? What is the basic difference? A, expectation value of A equal to I write in quantum mechanics. A stands for any variable. It may be energy, it may be momentum, it may be any arbitrary physical variable. Okay. Then I will write psi A psi. It will give An into P. Or if I write in energy, suppose, and expectation value of energy, I will write like this. Okay, you will get sum of E and P. Okay, this is in quantum mechanical view. Suppose if you forget this formula in statistics, how will you write statistics mean value? Whenever I consider mean value, whenever I calculate the black body radiation calculation, this is the sum of ER e minus beta E. Same formula. Okay, this is called partition function. This is energy into beta ER. It is similar to this equation. Now, this equation is similar to this equation. It is a total number. Total probability is a numerical value. This is also numerical value because beta has dimension of energy inverse. Or energy, this energy has a unit of energy, then it will be cancelled out, it will give a numerical. Similarly, this is a constant, this is a favorable event. So equal to AN or coefficient of wave function of that state into probability of that state. This is in terms of energy. So if I write here, if I expand here, suppose I can expand beta ER, okay, E1 e to the power minus beta ER, okay, next sum of e to the power, if I expand this term, E2 e to the power minus beta E. Okay, then what happened? This whole term in statistics, what we have learned in statistics, this term represents E1 into probability. Have you remember this equation? Total event favorable is equal to probability. So E2 P2, it goes like that. So you see, same equation is valid in statistics, same equation is valid in quantum mechanics. This is also expectation value, energy, mean energy in statistics, and this is also expectation value in quantum mechanics. All are same, only representation is different. If you remember this equation, you can recall this equation with the help of this equation. And if you recall this equation, then you can recall this equation. Then this is where you can merge quantum mechanics with statistics, and it will be easy for you, and you can cover the whole syllabus and within short period of time. So I will give a question, numerical problem that you have understood. Numerical question is given in NET exam. The one-dimensional question, one the harmonic oscillator, is in superposition, is the position of n state. N state is given by psi equal to 1 by rho 2 state rho 3 by 2 3 state. Find the mean energy. Okay. So solution. How can you find out the mean energy of this solution as part of previous solution? See, this is I can represent A1 phi 2. This is suppose 2. This is 2 state. That is why I write phi 2. This is 3 state. So that is why I write phi 3 state. Is okay clear? Now find the mean energy. So we have already know the mean energy formula. Mean energy formula is equal to sum of En into P. So En energy of the one-dimensional harmonic oscillator. We know the energy of the harmonic oscillator. From that formula, we will put the value. Okay. And how can you find out the P? So, in order to solve this equation, you focus on this part. Suppose this part is phi. What is the total probability? What is the formula of probability? In postulate 4 probabilistic measurement, AN, this formula is what? Total probability and this is the formula. Okay, it is although look like abstract, but it is very easy. Total, this is product of, this is a Brown notation, this is a Brown notation. Cat notation you find out with only reverse of this. The cat notation phi cat equal to 1 by 2 step. It is represented like this. So 3 by 2 3 step. It is now product with this and this. You will get only this term and this term. That means in this one. Denominator will give how much? 1 by 4 plus 3 by 4. It will be 1. Okay. And this is a step 2. Probability. And probability of this system staying in this state. This is the square. This will give what? This term. This is the step to multiply with this step. If you want to find the coefficient, this one, you have to multiply 2 step side. You will get this coefficient. So it will give only an square. So what we have already found, this formula we have represent a1 plus a1 phi 1, a2 phi 2, an phi. So in that case probability we will get, you remember this formula, I am writing again to make you understand. This will be, denominator will give sum of coefficient, numerator will give me, this is the formula. So what we can understand formula from the postulate 4, the total probability, this will give the coefficient of square of the coefficient. Square of the coefficient is sec. If the sum of the square of the coefficient is 1, that means wave function is normalized. Okay, normalized, then this probability becomes psi n square. This is the probability. This will equal to an square. Okay. Now probability of this formula is whenever this just sum the square of coefficient. This is square, a1 square plus a2 square equal to how much? 1. So wave function is normalized. No need to write the denominator part. Just square the coefficient of first part will represent the probability of finding this system and this type according to this equation. This equation equal to this one. So now we have to measure the expectation value. Answer is 3.25 is equals to this would be like this. So how can you measure a? This is a formula En Pn. So probability of the first state is wave function. Since the wave function is normalized, how can you know? Sum square of product of coefficient. This is 1 by 4, 3 by 4 equal to 1 by 2. Wave function is normalized. So probability is just the coefficient of first state. This is the probability. First one, E1 P1 plus E2 P2. So P1 will be how much? 1 by 4. E1, or this is sorry, E2 step. I will write E2. Otherwise you will get confused. 3 step. E2 step. E2 into P2. E2 step is probability 1 by 4. And E3 into each is the probability, this coefficient of this term. Coefficient of this part 3 by 4. So what is the value of E? En equal to, we know, one dimensional harmonic oscillator. A is cos omega. So E2 will be how much? 2 plus half A is cos omega. So it will be 5 by 2 A is cos omega. Similarly E3 will be 7 is cos omega by 2. Okay. So you put this value here. So you will get total mean energy equal to 1 by 4 into 5 by 2 is cos omega plus 3 by 4 into 7 is cos omega by 2. The answer is 3.25 is cos omega. This is the this way you have to evaluate. Okay. So I will give a more question, then you will understand in easy. Consider system, question number 1. Consider a system of one dimensional particle in box. Okay. Box represent. You read the question carefully. T This is the question. Question number 1. This is alpha. Question number 1. Find the value of alpha. First question. This question comes in a NET exam. What is the value? Or you may ask this type of question. Consider a system of a one-dimensional particle in a box with this function. This function means this wave function has 3 possible basis vector, or you can say microstate. With this coefficient, this one. What is the value of alpha? So how can you find out the value? Because wave function must be normalized. Okay, that means this wave function must be equal to 1. So how can you find out the value? This already phi cap is already given. So you find out the phi cap. It will be same, only reverse the notation. Okay. Whenever phi is already given in the bra notation and cat notation, you can just reverse the bra to cat. It will be 1. So first one will be what? This coefficient 3/9. Already I have given you total probability is summation of an square. An square means a1, a2, a3. So it will be 3/9, 2/9, 2/3, alpha square equal to 1. And alpha equal to, you can find the value of, I think it is 2b3. So this is the value. Okay. So alpha value is 2/3. Okay. Once you put the value of alpha, suppose I put this value of alpha, then I will try to calculate the rest of the thing. Okay. I have already find out the value of alpha. I put this value. Question is, question comes in the NET exam, and similar question comes. I will discuss more questions. First, I will try to understand. I will try to make you understand. So, once you find the value of alpha and put here, then no need to ensure. It is already wave function is normalized. No need to do anything. Now, second question is there. Question number 2. What is the possible probability? What is the probability of finding this system in state 2? What is the probability? Then how can you have probability? Probability 2 state. 2 state means psi 2 state. How can you calculate? This is formula. Now wave function is normalized. No need to write this part. Only formula is what? Psi n psi squared. What does it mean? You take this function and product with this. See, if you want to find the probability of this system with this state, then you multiply this wave function with this term, like this, psi 2 into this one. This part will be 0, this part will be non-zero, this part will be 0 according to the orthogonal condition. Okay, I try to show you one thing. This is the formula. So you have to multiply psi 2 into psi 0, x 0. Okay, then first term will be what? This is constant, no need to change anything. You just phi 2 phi 1 first term, second term will be 2 by 3 psi 2 and third term will be root 2 by 3 psi 2 psi 3. Okay. So what we understand, this part is 0 according to orthogonal condition that I have already given. Orthogonal condition is this one. I am telling you again. Psi m equal to delta mn. Delta is a direct delta notation. Equal to 1 when if m equal to n, equal to 0 if m not equal to n. Okay. This is m, this is n. This is 2, this is 1, not equal to 1. This is 2 not equal to 1, that is why this term 0, this term 0, only this term. So only this term means this is equal to 1, only you will get 2 by 3. So shortcut method is that if you set the wave function, whether wave function is normalized or not, say square sum, so it will be 3 by 9, 4 by 9, 2 by 9 equal to how much? 4, 3, 4, 7, 2, 9 divided by 9 equal to 1. Normalize, no need to do anything, just square the coefficient and represent the probability. Okay. So I can simply state probability in one state 1 phi 1 equal to 3 by 9. How can you calculate? Phi 1 into phi x0 squared. Okay, that's how can you calculate? I have already given you one example. Similarly, phi 2 state just coefficient 4 by 9 p3 4 by 9. Oh, sorry, 2 by 9. This is the probability. This means this. What do you mean by this probability? Probability means the possibility of this wave function stay in state 2 is this one, this fraction. Okay, and possibility of this wave function staying in this state is represented by 4 by 9. So possibility of this function staying in this phi 3 state is this one. Okay, this way you have to understand. Now again third way, this is the probability. Probability I have find out P1 you are getting P1 equal to 3 by 9, P2 you are getting 4 by 9, P3 you are getting 2 by 9. This is the individual probability. What is the mean energy? How can you calculate mean energy? Mean energy formula I have given you. Mean energy equal to sum of En Pn. This is the formula. And what is the state? Phi 2 1 3 state. Then you have to write E1 P1 plus E2 P2 plus E3 P3. This is the formula. So P1 P2 P3 I have already calculated. How can you calculate E1 E2 E3? This is already given one-dimensional problem, particularly in 1D box. Then you have to remember, you have to recall the energy energy in particularly in box n square pi square a square divided by twice n a square or l square equal. So E1 equal to how much? Pi square a square twice n a square. That was E naught. Okay, and E2 equal to how much? This will be 4 E naught. Okay, and E3 equal to how much? It will be 3 9 E naught. 9 E. So how can you calculate? So it will be E naught into P1. P1 means 2 by 3 or 3 by 9 plus 4 E naught into 4 by 9 plus 9 E naught into 2 by 9. Okay, 2 by 9. Then you just, this is simple product. So it will be E naught 3 by 9 16 by 9 plus 18 by 9. Okay, this is the reason. This way you have to calculate. It is very easy, not so hard. You just focus on the one-dimensional problem, then remember the energy expression. Suppose if it is harmonic oscillator, then harmonic oscillator formula n plus half a square omega, you put this value in accordingly. But confusion is arises that. But confusion. Suppose I am not giving this term. I am giving only two terms. Two terms. 2 by 3 phi t. See, now wave function is not normalized because square product is 3 by 9, 4 by 9, not equal to 1. Then what happened? Then you have to write denominator. So what is the probability? First probability, see. Probability formula is this one. An. Now you have already said this wave function is not normalized. How can you know? Because square of coefficient is not equal to 1. That's why you have to write denominator. This is the original formula. Okay, this equal to give sum of coefficient square. Okay, remember. And this equation I am not writing again. This is just A square. So probability of finding first state is what? First state. This is what? 3 by 9 plus 4 by 9. This is what? Divided by 3 by 9. This is the probability equal to 3 by 9 equal to 7 by 9. 7, 9 and cancel 3 by 7. Now this is the probability. If wave function is normalized, now this wave function is not normalized. Then PT state, now you have to PT state. Second PT state is similarly 3 by 9 plus 4 by 9. Denominator remain fixed and it will be divided by 2 by 4 by 9 equal to 4 by 7. Okay. So what I am getting? So probability P1 I am getting 3 by 7. Now do not, if the wave function, why I am telling you, if the wave function is not normalized, then you have to write denominator down. If the wave function, first of all you have to check whether wave function is normalized. If wave function is now in this case not normalized, in previous case normalized. If it is normalized, then no need to write denominator down. Okay. Then ET equal to 4 by 7. This is the probability. Okay. Now what is the mean energy? Mean energy, carefully you say. This suppose this is En, Pn. Okay. This wave function is one state. This is 3 state. It is also represented like this also. So you have to write U1 P1 plus Et Pt. Okay. Then you recall the energy formula. N square pi square a square divided by twice m a square. You can represent n square E naught. Okay? N square E naught. First one will be what? E naught into P1 3 by 7. 3 by 7. Next one will be 3 step. It will be 9 E naught into 4 by 7. This is the answer. This is how you have to calculate. In case of wave function is not normalized. It is easy. Don't worry. It is very hard. This way you have to calculate if this wave function is normalized. Now similar question asked in the NET exam. Another question. Okay, I will give you this in the next part, because in order to solve that question you have to know something basic, then you can solve it. Now solution of Schrodinger equation. It is very important. Solution of Schrodinger equation. What is the solution? So don't confuse and don't try to memorize everything. You just to recall the original equation, then you can easily understand. So what is the postulate that fifth postulate we have learned also? This wave function is equal to E psi. You can write like this, okay? This is the 5th postulate. In 5th postulate, we have written like this: is phi equal to E phi. It is in bracket notation, Dirac notation. So no need to write like this. Just simply write this for better understanding. Then this is Hamiltonian of the system. Hamiltonian means total energy of the system. Okay, what is the Hamiltonian? Hamiltonian we write like this: T square by twice m plus potential energy. Okay. So I will put here. This is easy, very easy. This is easy. T square by twice m plus b phi equal to E. Remember, this wave function is function of x and t. Okay, I simply write phi, but it is this function contain position coordinate as well as time coordinate as per requirement of quantum mechanical postulates. So I will write in, because you know this formula, minus I is cos del x. It is one dimensional. So if I write in three dimensional, I is cos, then you know this operator represents. This is the operator represent momentum part. Okay. So if I replace it, del square is cos squared by twice m plus b psi equal to E phi. Okay. And out I can replace E equal to I is cos del phi by del t. Is it okay? Now question is that left hand side is depend on position coordinate. It is totally independent of time. And right hand side is totally dependent on time. Okay, but they are equal. That means both are independent. Both are depend on different variable. Left hand side it is only depend on x. Right hand side only depend on t. But they are equal means there must be some constant. Okay, I will consider. Now remember, this part will give the stationary state solution, and this part will give the time dependent part. Okay, as per quantum mechanical postulate, there is a 5 postulate. Out of 5 postulate, 4 postulate give the static description of the system, and number 5 postulate will give time evolution of the system. At particular time, system will be where, in which location. Okay. Similarly, this part will give the time part, and this will be part. So, if I separation of variable, if I use separation of variable, if I want to solve this equation, similar equation, I have to put a function phi is equal to xt is equal to x phi x, this dependent x, and phi t, suppose t. Okay, and according to this equation, I consider it is a constant which is represent energy. Okay, this is equal to, this part is independent of time, this part depend on part, independent of x, but they are equal. That is why I consider it will be equal. Both are equal and equal to some constant E. Okay, and which represent a total energy of the system. Now I put the separation of variable. Okay, if I put the separation of variable, what happens? Separation of variable, if you put here, then minus a cos square by twice m del square phi means plus v, this is phi and t. This is equal to what? I is cos phi will come off. This will equal to d phi by d phi by dt by t dt equal to E. Okay. Now, if I take now this part, I is cos dt. Now I will write partial derivative. I write total derivative because it is only the variable t e. Phi is there, so it will be equal to dt by t minus I is I e by h cross into t. Now, separation of variable t. This will be like this. If we divide it, I simplify one step for better understanding. A square twice m del square plus v divided by t. T, then it will come on xt. Phi equal to I is cos del t by dt. T equal to t. Okay. So this means I separate the variable minus this equal to a square by twice m v square plus v phi. This part contain only phi equal to e phi. This part, and other part it will contain 1 by t equal to dt t. T equal to 1 by t. 1 by t is there, equal to this one, equal to dt by t minus I is I e is plus t. If you solve this equation, you will get t equal to e to the power minus e I e t by s. This is time part. And if we solve this equation, we always consider the solution. We will get a solution because this is a differential equation. So we will get a solution in terms of wave function. It may be complex function, it may be any other function. So we are not going to solve. The total wave function of the total wave function is represented as, it will give a solution. This will represent a n phi n, and this part, product of this part and this part, because I have originally written this wave function equal to phi x and t. Now I have to give the product of this part. This wave function is the solution of this differential equation, and this part will give this part. So I will get sum of a n phi n e to the power minus I e by s. This is the general solution of Schrodinger equation. This part will give the static information, and rest of the thing will give time dependent. Now, how can you understand the question in NET exam? NET exam is question, suppose question number 3. Consider a system of 1D system of particle, 1D one-dimensional particle in box. Has wave function. Wave function is represented like this: x0. Okay. 3 by 3 psi 1, 2 by 3 psi 2. Previous example. Root 2 by 3 phi 3. Okay. This is the question comes in, this type of question comes in the exam. So what is the wave function in this step? What is the wave function at time t equal to t prime? That means you have to answer. They are asking the wave function x t. this one. Okay, according to the solution of Schrodinger equation solution, complete wave function of the solution is represented as an phi n e to the power minus I e by t is equals. Okay, this equal to, you can simply write an phi n I e n t by s square. This energy, En is the energy according to the equation. It is energy, particularly in 1D box, you have to replace En with particularly 1D box energy. That is equal to n square pi square a square divided by twice m a square. So, this equal to how much? T by T. An means this one. Okay. Phi 1 means this thing. Phi 1 into e to the power minus I e1, now e1 t by a square. Okay. Next is very easy. 2 by t phi 2 e to the power minus I e2 is t by a square. Phi 2 state 2 by t e to the power minus I e3 t by a square. Now you put this value e1 equal to the value, you have to put en equal to, we know, n square pi square a square divided by twice m a square. This is the en. So you can find out e1 equal to this one equal to 1, then you put this value here. So equal to 3 by 3 phi 1 e to the power I pi square a square divided by a square twice m, it will be twice m a square into t. Similarly, 2 by 3 phi 2 I e2 means 4 pi square a square divided by twice m a square into t. Similarly, third. So this way you have to calculate. Okay, it's very easy. Similarly, if the particle harmonic oscillator, then you have to, from this equation will remain same. You just take the product of corresponding time part. Corresponding time part means if it is E1 state, then it will be minus I E1 t by s cross, and put this value of energy according to the equation. Now it is particularly in the box, that's why I am writing this formula. If it is particularly one harmonic oscillator, then you have to express this expression will change, n plus half a square omega, then you find out the value e1 e2 e3 like that, and put this value here. That is this equation, the time valuation of the system. This wave function is according to general solution of Schrodinger equation till that. General solution of Schrodinger equation is product of special term. The special term means wave function that depend on position only into time part. That will represent that will describe the whole system according to the 5 postulate. Okay, this way you have to understand. After completing, I try to complete this section according to the chapter. After that, I will solve the problem, all the problem as given in the NET exam and GATE exam, all other exams. And I have also a set of multiple questions. If you solve this equation, you can easily understand chapter 3, and you can easily understand the question given in the NET or GATE exam. But don't think that question is very tough. You only need to understand the question carefully. If you understand the question carefully, you can easily understand the answer, which is the correct answer. Okay. So another question is given. So another question is comes in exam. I am writing here. Question number 5. A particle in box. A particle in 1D box. 1D box. With infinite potential. Infinite potential. And wave function at t equal to with n. Wave function at t equal to 0 is given. This is wave function is given like 0. Wave function is given a by a sin pi x by a. This question you can understand only when you understand the wave function of particle in a box. Sin t pi x by a 1 by rho by a. This is 5 sin 5 pi x by a. Okay. See, in order to understand this question, you have some basic idea of particle in 1D box. The basic idea is that what is the wave function of particle in a box? You have to remember. Particle in a box wave function is this one. 2 by a sin n pi x by a. This is the formula. Okay, this is the basis vector. Now it will become as this C. This is in terms of basis vector. 3 step, 5 step, 1 step. N equal to 1, n equal to 3, n equal to 5. Okay, but here is not 2 by a. Rho a is there according to this wave function, but 2 is missing. So in that case, we have to modify the original equation. How can you modify? You see, I can write 2. I can write 2. Is it okay now? Pi x by a. Why I am writing? Because if phi 1 is equal to 2 by a sin pi x by a. Is it okay? Now it is 2. Now it is 2. That is why I give it 2 and 2 to cancel, it will remain same. Okay? That's why I write it. Otherwise you cannot put this function, you have to replace phi 1. It will make you easy to solve. Next here is rho a is there, but rho 2 is not there. I am writing rho 2. 3, rho 5, rho 2 have given externally. Okay, rho 2 by a sin 3 pi by x a. Okay, I am giving rho 2 and it will be cancelled, remain same. Is it okay? Then here is rho 2 is missing, so I write rho 2 5 rho 2 by a sin 5 pi x by a. Okay. Now you can replace C. You can replace now. What is the value? A by rho 2 phi 1. Okay. Now you can write like this. Otherwise, don't write like replace this term, because we know this wave function equal to 2 by a. This constant must be there everywhere. Sin n pi x by a. This is the wave function in particle in the box. Okay. Next, it will be about 10, 3 by 10. Now it is step 3, third step. Last one, 1 by 10, pi 5. Okay, I simplify this equation to this equation. Why I am simplifying? Because now I can solve it. Now question is given for what is the value of a. Okay, now you understand what is the basis vector. This is the basis vector. Suppose what is the meaning of this equation? That in particle in a box, consider a box, there is a one particle. Suppose it is electron. It has 3 possible microstep. Means it is 3 different states there inside the box. One state is this one state is this one state is this one. So electron can stay this state, this state, this state. So staying of electron means wave function. In this state is measured by the probability coefficient. And staying of this state means electron. In third state is measured from the coefficient of this coefficient. And this state we can measure. So in previous calculation. So it is very easy. I simply write this equation, the wave function. Wave function I simply write x0 a by root 2 I1 root 3 by 10 I t root 1 by root 10 5 by. Okay. What is the value of A? It's just sum product. Probability is equal to coefficient square. So this coefficient must be equal to 1. So product sum of square of this coefficient and this one must be equal to 1, which represent a probability. Means this one. This means what? Sum of this one. I have already derived the equation. So it will means it must be equal to 1. So it will mean a square by 2 and 3 by 10 plus 1 by 10 equal to 1. So it will be how much? A square by 2 4 by 10 equal to 1 minus 4 by 10 equal to how much? 6 by 10 equal to a square equal to 12 by 10. 12 by 10 means 6 by 5. So a equal to 6 by 5 rho. Okay. This is how you have to calculate. Now put this value 6 by. Now wave function I can put this value. 1 by root 2 into 6 by a 6 by 5 phi 1 3 by 10 3 by 10 phi 3 1 by root 10 5. Sorry 5. Now what next question? What is the wave function? This at 0 at time t. What is the time? This is called time evaluation of the system. How can you measure? Only see x t equal to psi x0 into e to the power that I have already given the solution. Now what is the general solution of solving the equation? Sum of an phi n into e to the power I e n t by a square. This is the general solution. So this part is already here. This part. This is a n means coefficient, and phi n means phi 1, phi 3, phi 5. Okay. This is sum e to the power I. No need to sum. You just understand. E n t by a square equal to how much? First term will be this will what? Root 6 by 10. 6 by 10 phi 1 into e to the power I e1 t by a square. Okay. Next one will be 3 by 10 phi 3. You have to write 2. Don't write 2. Okay. According to the state of the system, you have to replace the energy. So it will be I e3 t by a square. Next one will be 1 by root 10 phi 5 e to the power minus I e5 t by a square. So e5, e1, e2, e3, because it is particularly in a box, you write expression en equal to n square pi square a square divided by twice m a square. So e1 equal to this is 1. So pi square a square divided by twice m a square. E3 equal to, it is suppose e naught. E3 equal to 9 e naught. E5 equal to 25 e naught. Put this value here. Here. This is the answer. So this way you have to solve. Okay. So this whatever we are discussing today is studying the wave mechanics. In the next many things we have discussed, we have to discuss in this chapter. Once it is complete, I will go to the numerical question. All the possible numerical question comes from this chapter, and then next in the next chapter, chapter number 4, we will describe whole the system in Heisenberg matrix mechanics we will discuss, because both are equally important. Sometimes question comes in wave mechanics, matrix mechanics, and sometimes it is wave mechanics. Okay, don't confuse and try to learn according to the topic given in the Zateli book. Zateli book is the best book. If you follow, strictly follow, you can answer all the question and you can easily qualify. Okay, thank you.